Hello everyone, how is going? I hope good. Welcome to the first Italian Spring Boot meetup. Few weeks ago, with VMware, our sponsor for today, we thought about this meetup. I am Giorgio, and today we are live on Italian Coders Facebook and YouTube channels. We decided to make a series of Java Spring meetups during this year. And today, for the first live, we have a great talk about cloud native Java. Italian Coders is an Italian tech community, and we have many channels. In this slide, you have all the links for joining us. We have a YouTube channel with more than 1,000 of subscription, a Facebook group, Spring user group, with more than 2,000 members, and a Discord server. In a Discord server, we talk about with many different arguments, but today we are here for Java Spring Boot ecosystem. Our goal is a series of a Spring Group meetup. VMware helped us with amazing speaker. For example, Spring Core committer. But our idea is to invite also local developer. So if you want to submit your talk, you can scan the link and follow the instructions. You can talk about Spring topics, for example, Spring integration test, Spring Batch, or Hibernate. Today we have an English talk, but the next meetup could be in Italian. You can also send an email to italiancoders@gmail.com with your abstract. For a great talk, we must have a great speaker. And today we have a very passionate developer, Java champion, and a Spring developer advocate at VMware. Welcome, Josh Long.
Well, hi. Can you see me or hear me or anything like that?
I hear you, but I didn't see you.
Oh, whoops. I just realized
Okay, now it's better. How is it going?
Sorry?
How is it going?
Oh, it's good. It's good. It's very good. I'm very happy to be here. Thank you for having me.
Okay. Please use the comment for questions and we will answer during the Q&A. Josh, the stage is yours. Enjoy.
Thank you very much. Okay, everybody. I appreciate this. Let's see here. Share screen.
Okay. Perfect.
Okay, you can see?
Yeah.
Okay. All right, where's my slide? Okay, everybody, good stuff. So first of all, thank you very much for having me. I'm so happy to be with you here today. You know, I'm a little embarrassed that la tristezza è che non ho parlato italiano 20 anni, 20 anni fa che non ho parlato italiano, allora mi fa tristezza. Però, you know, if you want to practice with me, I would love the help. It's been a long time, you know. Ho dimenticato la miglior parte della lingua, tristemente. But I love Italian, you know, so one day maybe I can come back and I'll learn it again. I studied it for 7 years in the 90s, you know, for a long time, starting in the 90s. So I miss the language. I miss Italy. I miss all of it. So I'm very sorry that I could not be there with you in person, you know, together live. So, okay, let's see. Whoops, wrong slide. Oh, dear. Oh, dear. You have to be careful. I have to be careful. Sometimes I forget the slides. Okay, so I appreciate that you're all here today. I appreciate that there are places that you could be. You could be doing other things, but you're here with me today. So I really appreciate that. My name is Josh Long. I work on the Spring team, and I work as a Spring developer advocate. I've been a part of the Spring team since 2010. As part of what I do, I have, I get a lot of questions. So I want to start with this Twitter handle and this email. So if you have questions, please don't hesitate to send me messages on Twitter or on email. I also have a book I just wrote called Reactive Spring, and I have a YouTube series, and I also have a podcast. Oh, I forgot the podcast. Food-P4podcast.fm. Okay, so there you go. And so these things are just places where you can find all sorts of content about Spring, about the ambient ecosystems, etc. Right? So lots of stuff going on there, and I encourage you to check it all out if you have not already. We're going to talk about cloud native Java today. We don't have a lot of time, however, so we're going to talk briefly about cloud native Java. And what I want to talk about specifically are things that allow us to build better software that's intended for the web, right? Intended for the cloud, right? For production. It's very important whenever I feel it's very important whenever I speak to talk about what motivates our move to the cloud, right? When I think about the cloud, I think about the business context, right? Why do we care about the cloud? Well, we care about the cloud because the cloud allows us to go faster, but it is not the only thing that allows us to go faster, and it is not the reason that we want to go faster, right? The reason that organizations want to go faster, the reason that businesses want to go faster is because they know that speed allows them to make more mistakes and to learn from those mistakes. That is to say, the faster you go, the more experience you get. Some of it is good, some of it is bad. And so really what we want before we do anything is to go faster. That's what we want. We want to learn more. We want to be able to grow faster than the competition. And so we look to our software and we say, well, this software, we can code more quickly, maybe, if we do continuous integration, or if we do test-driven development, or if we do agile, or whatever, right? There's all sorts of different practices that we can do here, but that's specific to the developers. It's specific to the technology section, right? To the IT department. What we want is to make sure that as an organization, we are all trying to move faster. And so this is not always very easy, but just keep that in mind. Just remember, if you truly want to benefit from speed, the whole organization needs to be a part of it. You can't have just the developers going quickly and then have the rest of the organization acting like it's waterfall, right? I see this a lot. We call this water scrum fall, right? We have waterfall around the IT, and then IT is agile, sort of agile. So it's not good, right? So that's the first thing. We want speed so that we can learn. Organizations should embrace speed. The other thing that we care about is understanding the big picture here. When you build software that's intended for the cloud, you have to build software that handles the ups and downs, that handles the volatility, it handles the any problems in production, right? This software is what I mean by cloud native Java or cloud native software. It's software that's intended to handle the environment of the cloud, right? The dynamic, scalable environment of the cloud, where things can change very quickly, where new services are coming and going all the time, etc. Right? This elastic behavior changes the way that we have to write software. When you start moving to microservices, when you start moving to test-driven development, your goal is to go faster. And so one of the things that you do to go faster is you focus your small teams. You have small teams of people, and they're working on the software. This small team of people is focused on one thing, one feature. And so there's not a lot of synchronization. These people are not spending time asking other people in the organization for help. They don't need to. They can just deliver what they're trying to deliver and focus on this one thing. They don't have other work to do. This result, if you have a small team working on a small code base, gives people the ability to go faster, allows small teams to think and move independent of other parts of the organization. And that's very important, right? The ability to go independently of other parts of the organization. So the question then is, what happens if you have small teams building small code bases, deploying independent of other parts of the organization? Well, of course, if you want this to be truly independent, then these things that you deploy cannot be linked, at runtime. They cannot be a jar in the class path. They have to be distributed, right? Because if I deploy this service and you deploy that service, I should not have to wait for you to deploy that for me to deploy this, right? It's very important that we can do both at the same time or at separate times without having to constantly slow down somebody else to make it work. If you can do that, if you can deploy small, singly focused, independently deployed microservices, then you can go faster. You can have small code bases. You can have small teams of people that are able to move more independently. And the question is, when you have lots of microservices in the cloud and they're now talking to each other, you've now got new problems that you did not have before, especially in the monolith world. These new problems are not so bad that you should not do this, right? There's a good use case for building cloud native software, but you must be prepared. You must understand that sometimes things will fail. And so writing cloud native software is all about writing software that deals with that reality. Excuse me. So I'm going to talk to you today about several different patterns that you can embrace to build more reliable, more scalable cloud native software. And one of those things that really helps us out when we build cloud native software is reactive programming, right? Reactive programming gives us a way to describe software. Hello. Huh. Hide that. Okay. Yeah. Reactive programming gives us a way to solve three problems, three big problems. The first problem, the first concern that we have is how easily can we compose different types of data, right? If it's coming from a database, from a web service, from an RSocket endpoint, from a WebSocket, from HTTP, from whatever, right? A message queue, etc. With reactive programming, we have one abstraction, one API to handle all of these different abstractions, to handle all of these different types of data. So reactive programming makes it easy to compose, okay? The second thing that it gives us is it gives us a toolkit to handle the potential failures in production, to handle where there are errors, where there are things that can go wrong. And then finally, the third thing it gives us is it gives us a way to write code that is more multi-threaded and more resource efficient. That is to say, it doesn't waste threads and it scales better, okay? So these three things are, I think, very important when you build cloud native software. They give us a lot of reliability without a lot of work. So I don't have a lot of time to really dive into reactive programming, but we're going to build two services, okay? The first service is going to be a reactive web application using HTTP and Lombok and the actuator, okay? So there you go. I've got the actuator, I've got Lombok, I've got the reactive web stuff. I'm going to call this service the customers service, okay? I'm going to use the Eureka service registry. Actually, you know what? I won't do this. Maybe I'll use the config client though. So we'll add this. I've got the reactive web support, Lombok, the actuator, and I'm going to use an embedded in-memory SQL database here. I'm going to use H2, and I'm going to use R2DBC. Now, R2DBC is the reactive relational database connectivity abstraction. It's an abstraction for doing SQL data access using reactive APIs. Now, reactive APIs are different than regular APIs because they assume an inverted control flow. They assume, they work because it is assumed that when you ask for data in a reactive API, you will not sit there and wait for the data. Instead, you've registered a callback and you'll receive a callback when the record is available. And so this is asynchronous, right? I ask for data, and then I go do something else. And when the data is available, I am given a callback. Okay, a callback happens. So this is enough. I think I have everything I need here for my services to for me to describe a very simple service, right? Okay, so let's see. Here we go. Generate. Let's load this into the IDE. Okay. Oh, I have an application. Let me make the font a little bit bigger. I have my application. It's a public static void main application. And all I want to do is I want to make this application talk to my SQL database and give me an HTTP endpoint, okay? So I will build an application to manage data of type customer, okay? So private integer ID, private string name, and the ID will be mapped to this object, which my ORM, my Spring Data RTDBC, will persist for me. I'm going to create a repository, a reactive repository, extending the reactive CRUD repository interface. The reactive CRUD repository provides methods that support saving, finding, counting, deleting, etc. All of that should be very familiar. Maybe you have not seen Publisher before. Publisher is kind of like a completable future. It's a thing that publishes data asynchronously, and the consumer can register interest in that data. It can consume the data asynchronously. There are two specialized types of publisher. One is mono, which is like a publisher that produces at most one value, maybe 0, maybe 1. And then you've got Flux, which is a publisher that produces many values. It could be 0, it could be 2, it could be 5, it could be 1,000, it could be 1,000,000,000, it could be infinite. Okay, so we have these two reactive types, and we have a repository. And now I want to save some data to the database. So I'll create an application listener for the application ready event. Okay, and what's going to happen is when this application starts up, I'm going to get a callback event that I can then use to write data to the database. So I can inject my customer repository here. I'll say customer repository. And here, I want to save some data. So I'm going to create a reactive stream full of names, people on the Spring team, let's say. Stefan. Okay. Some of these people. Let's see who else. Who else? Etc. Okay, good. So there we go. There's our names here. And I'm going to take each name, I'm going to map the name into a new customer. So like so. And that gives me another reactive stream. Notice that it's a publisher of customer, right? And now I want to save this to the database. So I say customers flat map, or that map customer, and I'm going to say customer repository dot save. There we go. Now the problem, of course, with this is that if I evaluate this variable, you see I have a publisher of mono of customer, and that's because this lambda right here, it returns a mono of customer. Okay. Well, I don't want a mono. I don't want. This is both. These are both publishers, right? So it's very, it's not what I want. I don't want two publishers. I want just one, right? So what I want to do is I want to flat map I'm going to take the inner publisher and flatten it. So there we go, save data, okay? There's my saved data. Now, if I run this code right now, if I run the program, nothing will happen. And the reason nothing will happen is because I have not actually, I just remembered I have to remove that for now. The reason that nothing will happen is because I have not actually subscribed to the data. So if I go here and I say subscribe, then something will actually happen, right? I can let's see, publisher. There you go. I can run this code right now, and this subscription is where the data starts moving, right? This is like a pipeline through which data will flow, a pipeline through which water will flow. But you must turn on the water in order for the data to flow. So this is what the subscription does. Subscription turns on the water. Okay, so if I run this code right now, the problem is that I've got, what is it now? This is 1, 2, 3, 4, 5, 6, 7, 8. I've got 8 names, and I want to make sure that those names don't exist already. So first, before I do this, I will actually say, I will say custom repository delete all, and then I'll say saved, and then I'll say I want to find all the data, and I want to print it out, and then finally I want to print out the results using subscribe. And subscribe, there are many different callbacks here, right? So this is a callback. Okay, so now I've got a slightly different code. I've said delete everything, but this returns a reactive type. It returns a mono void. So then after this is finished completing, then this will execute, and then the find all will execute, and then finally the results will come back. Okay, so this is the entire pipeline. Now, of course, you can simplify this code a lot, right? This doesn't need to be so verbose. You can tie things together a little bit more easily, right? There we go. Names. There we go. So there's my reactive pipeline now, much simpler. Let's run this and see what we get, okay? Oops. What did I do wrong? Table customer is not found, okay? So I need to create the DDL for that. And to do that, I'm going to use the R2DBC database client. Okay? So here, I want to initialize the database. I'll say create table customer ID serial primary key not null name var 25 not null fetch dot rows updated. So that gives me a DDL update mono, right? So I can do the same thing here as well. I'm going to say DDL update, then, right? Very simple. Just chaining things together just like before. So run the DDL, then delete. Well, we don't need that anymore, right? It's going to be deleted. Oh, actually, we can do that. Create table customer if not exists. Okay. Okay, let's try this now. Okay. Let's see here. Oh, is it the other way around? There we go. So there's my data in the database. Okay, you can see the database is it has my 8 records. It's working fine. So now I want to build an HTTP endpoint. So here I'll create a REST controller. I'll say customer REST controller. Okay, and here customers, publisher, customer, and all I want is I want to use my repository here. Excuse me. Okay, there we go. Good. So this is my find all. Let's restart this. Okay, so there we go. Localhost customers. Okay, there's our data. Okay, so now we have an application with some data. I want to go to production. Well, first things first. I want to make sure that this is ready to be in production. So part of that is I have the actuator. The actuator are a set of managed HTTP endpoints. There's even particular support for Kubernetes liveness probes, right? Liveness and readiness probes. So I want to make sure I enable those. I'm going to expose all the management endpoints. You should not do this usually, right? Do not do this in production, right? Only good for development, but I still want to do that. So I will include all that. And I want to say health always. So I'll restart that. Okay, good. So now there's my configured health endpoints, right? So these are things that I can configure in my application Kubernetes deployment. When I create a deployment and I want to configure the liveness probe and the readiness probe on the pod, I can do that by pointing my configuration to actuator health. And here you can see I've got two other groups, liveness, readiness. Now, liveness tells Kubernetes, it tells your platform whether the service is healthy or not, right? Readiness tells it whether the service has finished starting up and whether it's healthy when it first starts up. So readiness is what the platform uses to decide whether the service is ready to start production, right? To start work. Health, the liveness tells it whether it's still healthy, whether it's not sick. And so these are very useful. Now, let's say that this endpoint, liveness, let's imagine that for some reason this is down, okay? And you can change this, of course. You can actually, let's say I create a new endpoint here. Okay. Okay, availability change event, .publish. Application context. Okay. Availability state. So it's going to be liveness state dot broken. Okay. It's returning. There you go. So I'm just returning when somebody posts that, I'm going to publish an event in the application context that says that the liveness probe is down. So here's the probe right now. And then go to the console, curl -x post HTTP localhost 8080/actuator/health. No, sorry, not wrong. That one. We want this one down, right? So go here. And then it is down, right? So this is a way to change the state health, right? The state of the health of the service. Once you've done that, the service will be down. Kubernetes will discover that the service is down, and it'll remove it from the load balancer. The question, of course, is how long should it wait before it kills the pod, right? We should take it out of the traffic immediately. No more new requests. But you might have transactions that are happening right now, and you want to make sure that those finish. And so you can actually configure that using graceful shutdown, right? So server shutdown is graceful, not immediate, right? This is graceful means that it'll wait a certain amount of time before it shuts down. So that way you can finish whatever work you were doing. Maybe you have some web requests that are happening. If you want to configure how long it should wait, you can configure this, the timeout per shutdown phase. So here, it'll wait 30 seconds before it shuts down and shuts down the application context. You can configure Kubernetes to do the same thing so that it will wait 30 seconds before it kills the pod. Now, I have this. The only thing I care about now is how do I get my application into production? Now, you can easily create a container here, right? You can create a Docker file if you want, but there's a nice feature that's built into Spring Boot, in the Spring Boot Maven plugin. right? Spring Boot Maven plugin. And all you need to do is do Maven Spring Boot :build-image. Now, by the way, I'm running right now on my Apple Silicon laptop, Apple Mac, the M1. And so Docker is a little, let's see if this works. Okay. So you see what it's doing there? It's now downloading these things called build packs. These build packs are a Cloud Native Computing Foundation project. They provide a way to take an application .jar or .exe or Ruby on Rails or PHP or whatever, Django or Python or whatever. It takes that code and turns it into a container. That container you can then tag and then push to your container registry, Docker Hub or Google Cloud Container Registry or whatever, right? The benefit of this is that now you don't have to worry about how to write the Docker file and all that stuff. It's just done for you automatically. And it's just a regular container afterwards, right? So it's building the thing right now. This will take about a minute. This is not something you would run every single time you restart the application, but it is something you can run whenever you're in the CI environment at the very end, right? You can deploy your container to your artifact registry. So this is a very convenient tool, this build packs, right? You can still write a Docker file if you want to, but it's so valuable to have these build packs do the work for us, right? But this is not the only way to do it. It doesn't matter how you do it, but whatever choice you make, I recommend that you choose something that is consistent, right? So if you're going to use Google Gib, then use that for everything. If you're going to use build packs and Spring Boot's built-in mechanism, then use that for everything, etc. Right? So Docker run. There we go. Whoops. Oh yeah. Okay. This is the problem here. It's I'm running on a different platform than this, but that does work, right? You can run that now if you have a different Linux, if you have a different architecture, right? So, okay. But either way, I've got this image here, right? I've got Docker images, right? So let's see here. Docker images. Okay. Docker images. Okay. And we're looking for customers. That's this one right here, right? That was just created. So that's the image that we just created right now. So that's a very simple example of how you can create a Docker image and then deploy it to your Kubernetes cluster, right? So now I have an application that supports customer data. I want to create another microservice that supports order data. Now the thing is, here I will not use HTTP. Here I'm going to use a binary protocol from Facebook called RSocket. Now RSocket makes it very easy for me to do service-to-service communication. It's much faster than HTTP or HTTP2 or gRPC and so on. It was created by engineers at Netflix who went to Facebook, and the result is something that gets past some of the limitations of HTTP2 and gRPC and things like this. It's a binary protocol. Let me see, RSocket, we want a config client maybe. And I think that's it. It's a binary protocol. It supports multiple message exchange patterns. It's bidirectional. It's just a very useful technology. And it's also very easy to use in Spring because it's natively reactive. It has taken all the ideas of reactive programming and put them on the network protocol itself. So you actually have this concept of back pressure, which is a way for one reactive stream type, like a Flux or a Mono, to tell another that it is too busy to handle the data, so it can push back, okay? So what we're gonna do is we're gonna create a little in-memory controller here, right? A little in-memory database here. So we're gonna create an RSocket controller, order RSocket controller, okay? Is this, and I'll say private final map, and here I'm just gonna create a little in-memory database, right? Not a real database, for a class of data. And of course I could store this data in a real database, but again, it doesn't matter. We just a very simple example here. New concurrent. Okay. Okay, so there's this. And what I want to do is I want to say for each customer ID, Okay, customer ID plus plus. Then var orders is an array list of orders for var order ID equals 1, order ID is less than or equal to math.random times 100. Okay, 1,000, whatever. Okay, and I'm just going to create some random data. I'm going to add some random data here to my list. So I have some sample data that we can look at. And the order itself will have a customer ID and an order ID. Okay. Or it's constructor. Okay, so customer ID, order ID. Okay. So I'm just creating a list, and here I'll say this.db.put customer ID orders list. Okay, so there's my random database. Now I want to create an RSocket endpoint that reads that data. So I'll create another controller endpoint here, but I'm not going to use git mapping or something like this. I'll use this. I'll say orders.customer ID, publisher of order, get orders for, and I'll inject a variable here called a customer ID. So customer ID. And see how this is very similar to using the Spring MVC style controllers for HTTP, but we're not using HTTP. This is an RSocket endpoint. So I'll say this.db.get customer ID, and of course I want to turn this into a reactive stream. There's that. Good. So there's my entire brand new RSocket endpoint. In order for me to create an RSocket service, I need to have the RSocket port. So I'll say 8888. There we go. Actually, you know what? 8181. Good. So now let's run this, see what we get. Okay, it's up and running. So now curl HTTP. Oh, sorry, no, I want to use RSocket. So I'm going to use RSC TCP localhost 8181, and the route will be orders for a customer ID, like 2. And the interaction model is a stream. I'm asking for one piece of data, and I'm getting more than one record back, right? So there's my data. Right? Okay. So now we have our data. We have the RSocket results. We have the HTTP endpoint as well. Now I want to build a gateway, something that works with both streams of data. Okay, so here is where we can go back to start.spring.io and build a new gateway application. And here we're going to use the reactive web support. We're going to use Spring Cloud Gateway. And I think that's it. I think that's most of what we need. We need the RSocket, the Lombok, the config client, maybe the reactive web, and the gateway support. Okay. This gateway is going to be the first thing that comes into it's going to be the thing that receives the first requests coming into the network, right, from the outside world. So this is a great place to do generic cross-cutting kinds of manipulations. Maybe I want to require an OAuth token, or to redirect, or to do routing, or to do load balancing, or compression, or anything, right? You can do that in a generic way here. This is the edge service. It's the first service that your client will see before it goes to the downstream microservices. Okay, so I've got this gateway code, and we're gonna build two things. First is an API gateway, and we're gonna build that API gateway using Spring Cloud Gateway. Now, Spring Cloud Gateway is awesome, right? So Applicator Builder. And the idea is that you use this API, turn route.build, and you're going to build a route specification. So what I want to do is I want to say, when requests come into this port on port 9999, I want them to get processed by the Spring Cloud Gateway code. And the Spring Cloud Gateway is going to have the configuration for a route. And the route has three things. First, a predicate, right, or predicates. This can be the things that have to match. So host, right, whatever. Okay, that's my predicate right there. Predicate, And then finally, I need to have a URI to send the request to, right? So here, I'm going to send the request to, what did I say this one was? The order service, the customer service is, what port is this? Port 8080, okay? So I'll send this to port 8080. Now, I said that there are 3 parts. So here's the predicate, here's the destination. In the middle, you usually have filters, right? So here you can do all sorts of things. I can add filters, I can modify them, I can change the request body or the response, I can redirect, I can do retries, I can secure the headers, I can modify existing headers, I can change this content length, I can do all sorts of things with the response, right, that I could not do otherwise, right? And so this is a very nice way for me to process incoming data. And you can create your own gateway filter as well, right? So for example, if I wanted to do chain.filter exchange, I could do that, and I could also, do on finally on let's see, terminate. There you go. Done, right? That kind of thing. You can also before, right? You can put it before. Now remember, this is reactive, so you can't do it. This is not after, right? This actually has to be in a callback like I did here. So something like that, right? Or do on, let's see, do on cancel, do on discard, do on each, do finally. That's the one, right? Signal after. You can do all sorts of generic filters here. You can add things, you can do all sorts of really interesting things here. So let's see, filters. I've added a custom filter. That's one thing. I want to set the path. And the reason I want to set the path is because when the request comes in to localhost port 9999, it will have a path of /path, or let's say proxy, okay? And I want to change this path. As long as this path is present, as long as this host header is present, then I want to change it so that the path is now customers, right? So I'm going to send it to the customer service and to the customer path. Right, that's what I'm doing there. Okay, so I can do this very convenient thing here. And you can do all sorts of things. You can rewrite the path. You can say, oh well, if the request that's coming in, segment, whatever, right? This kind of thing. You can match it, right? You can do matching against the incoming thing, and then you can say, okay, well, I'm going to use segment here, right? Whatever, that kind of thing. So you can do all sorts of very dynamic things. You can write business logic, lots of great rules. There's nice things like rate limiters, right? You can use a rate limiter here. Rate limiter, right? So you can configure a rate limiter that will actually restrict how many requests are sent downstream. Okay, so let's restart this and see what we get. Okay, so curl HTTP localhost 9999 / proxy -v -h host test.spring.io. Okay, and there you go. I can see the data here, right? But if I do get 404 not found, right? So very, very convenient way to create a gateway to introduce dynamic behavior, right? Like rate limiting, like retries, like compression, etc. And I've showed you this interface here. I'm using this builder, but this interface is just a very simple interface. It has one job: give me a reactive stream of routes. And these routes you can build pretty easily, right? So you could store these routes in a database. They can be stored in configuration. There's even a Spring, there's a property file way to say it. So you can say routes like this, right? So route equals, and you can define it in configuration. If you don't want to write custom Java code, as I did here, then you can store it in configuration. And the benefit of that is that you can then refresh that configuration, okay? So now I've got my gateway code. This is very useful for generic kinds of cross-cutting concerns. By the way, this DNS is because of my Apple M1. Something about that. If I do this, Maven, okay. Restart. Okay. See, no errors this time. There's something about my brand new MacBook and Netty, the Netty under the library there. So anyway, there's my data, there's my gateway. Now I want to build instead of just a gateway, I want to build an API adapter, something to take the data from downstream and transform it. So I'll build a CRM client, and here I'm going to have, I'm going to need the DTOs from both other services, right? So an order, customer as well. Okay. Good. Okay. So customer, order, etc. Okay, so there's my two different DTOs. And what I want to do is I want to build a transformed view of the data. So I need to use a component. Okay, and here I'm going to have an endpoint to get all the orders for integer customer ID. And here I'll say return an empty one for now. Good. And I want to have another one for the customers. There's my two different streams, right? And what I want to do is I want to connect to the HTTP service. So I'll say private final web client, and I'm going to inject that into the constructor. This web client is a reactive, non-blocking HTTP client that I can use to make quick, make it easy to connect to other HTTP-based services. And so I'm going to build an instance of it. And in order to connect to my RSocket endpoint, I'm going to need something called an RSocket requester. Okay. And the RSocket requester is a non-blocking reactive RSocket requester is like a client, except that in RSocket, when one side connects to the other, they stay connected. There's not a constant reconnect each time. And so as a result, as soon as one side is connected to the other, they stay connected, and the cost of sending data over the wire is much less because you don't have to wait for the handshake. Okay, so now I have the RSocket requester and the web client, and I want to use those here. So I'll say for the HTTP, I'll say this.webclient.get URI HTTP localhost 8080/customers. I'm going to receive the data, the JSON data, and turn it into a reactive stream of customer. Okay, and then here I'm going to use the RSocket requester. I'll say this dot RSocket requester route will be orders dot customer ID retrieve. Let's see, we're going to retrieve a stream of order, right? And then right, so there we go. That's actually the entire stream. There's the entire actual interaction there. So I'm going to ask for the data at this endpoint and get it back and turn it into a stream of orders. That's all, right? I don't have to specify the URL because that's already done in the connection for the RSocket requester. So now I have an RSocket client and a HTTP client. And now what I want to do is I want to build a new view, a new adapter, an API adapter to show me all the customer orders. Okay, so I'm going to compose, I'm going to do scatter gather kinds of service orchestration and composition. So orders. Okay. So there's this. Good. So now I'll build a new view, a new reactive stream where I'll get both pieces of data, right? Get customer orders. integer customer ID. Actually, you know what? Let's just get all the custom orders. There you go. So say return get customers map customer, and then what I want to do is I want to call the microservice to get all of the customers. That's what this is going to do. And then for each customer, as it arrives back, I want to call and get the orders for that microservice. So it's a 1 plus n problem, right? So I'll say get the orders for customer.getID, right? I'm going to turn this into a list. So it's going to be a mono of list. Now, here's the problem. When I call flat map, the result of this will be orders. Right? Oh, no, it'll be a mono of list orders, right? This is a, oh, no, what is that? You can see either way, I don't want this. I don't want a flux of list of orders. What I want is both the orders and the customer. So I'm going to take this, say mono.zip, and I'll create a mono.just for the customer, and then that over there. And so what this will give me is a stream of tuples. A tuple has two types, customer and list of order, right? Results. And I can take each result, I can say return results.map tuple, new customer orders tuple.get T1 is the customer, tuple.get T2 is the orders, okay? So this is going to do network communication concurrently, right? I'm going to launch a request to both the customer service and the order service, and I'll get back the results at the same time, but you don't see any threads here. There's no executors or runnables or phasers or semaphores or countdown latches or anything like that. It just works. So now I can go here and I'll create a new endpoint. And then this time, instead of using the controller style, I use the functional reactive HTTP routes, right? So route build.get customer, we're just going to call the COs, there you go, new handler function. And this is a different style to building HTTP endpoints. You can build controllers or you can build endpoints like this. Either way, very, very convenient. So here, CRM client, okay. Get customer orders. And there's my entire application. Okay. Good. Start that. So now let's restart this and see what we get. Localhost 99.99 COs. Localhost. Oh, the RSocket service, is it not running? 8888, 8181. Ah. Okay. There we go. So there we go, my friends. We've got an endpoint where I'm calling the customer service and the order service for each customer, right? I'm taking the data from two different microservices, one of which is in HTTP, one of which is using RSocket, and I'm aggregating it together. I'm using reactive APIs. This gives me back pressure. It makes my services more scalable. I get better multi-threaded efficiency. And I get a bunch of very convenient operators in Reactor that help me make my code more robust. So things like retry or retry dot back off 10 duration dot of seconds, you know, this kind of thing, right? I can do, what is the issue here? Retry dot back off. Okay, what's the deal? Retry. Oh yeah, retry when. There you go. Retry that. And so I get very convenient things like this. I have operators to allow me to handle errors, etc. Right? I can just return empty, for example. I can gracefully degrade. I can do timeouts. Right? There's all sorts of operators that are built in to this to these reactive APIs, and it allows us to make our network calls more reliable, right? More safe, more scalable. So hopefully, my friends, you've learned something today. We've just covered a number of different patterns. We looked at reactive programming, kind of. We looked at building HTTP services. We looked at the Spring Boot actuator. We looked at patterns for Kubernetes. We looked at service orchestration and composition using reactive APIs. We looked at RSocket, which is a very scalable, very, very fast binary protocol from Facebook and from Netflix. And by the way, RSocket is super exciting because right now the Spring team has integrated RSocket into Spring itself. Alibaba, a large e-commerce company in China, they are using Spring everywhere, right? But now they also have a lot of work that is being done around RSocket. There's even work being done in the Java ecosystem at the Reactive Foundation, which the Spring team is a part of, to build a RSocket broker, right, which can act kind of like a service registry or like a message bus. It can do some very interesting things. It can also act kind of like a proxy for certain use cases for RSocket. RSocket has full support in the Spring ecosystem. You can do security, you can do messaging with Spring integration, you can do all sorts of different things with RSocket. So I hope you will investigate that. My friends, thank you so much for your time today. Grazie mille volte per venire. I appreciate it. If you have any questions, I'm happy to answer them. And I just hope you're having a wonderful day, that you're healthy and safe, and that we get to meet again one day. I hope to come to a physical meeting one day, hopefully.
Really interesting talk, and we have a few questions. Okay, I will choose this one. Okay, how are two DBC library can async an Oracle JDBC? I mean, I can use R2 DBC, but Oracle JDBC is still waiting the response.
Wait, so okay. So this just happened yesterday, like literally yesterday. Where did I see this? Can you give me 1 second? I'll find it. So basically, the RSocket, the R2DBC support for Oracle is expected at the end of this month, right? So I know you've been waiting, and let's see here. What did I do? Let's see, my profile, my Twitter. I just retweeted it yesterday, like literally yesterday, but I retweeted a lot of things. Okay, here, I show you. So here.
So follow him on Twitter because he's a really passionate developer. And
yeah, I would appreciate that. So can you see this? This is the Oracle blog. Is it streaming?
You have to share the screen. Okay, now yes.
Okay, so this is Oracle developer blog, blogs.oracle. And this came out January 21 of this year, so 7 days ago. New Year's goodies, Oracle JDBC 21, blah, blah, blah. Okay, so all this, very good stuff, fine. And then the last paragraph, right? I have also promised the availability of the first drop of the Oracle R2DBC driver. The bits are ready, but we need to clear some legal and security sign-off. So late January is a good expectation. this is all I know, but I'm excited because that means it could become soon, So there's R2BBC drivers for everything else except for Oracle, basically. And this is the last one. So if you want to do SQL Server or H2 or Postgres or MySQL or MariaDB or MySQL or SAP HANA or whatever, there's already an R2BBC driver. But now there's going to be one for Oracle too. So great question. It's coming soon. I'm expecting it to come soon.
Okay. Another question is, did you think it's good to add Prometheus to project even if we have a Helm stacked for log? I feel like I can already have a good monitoring with Helm stack and Grafana. Is Prometheus overkill?
No, I mean, obviously, your organization might be different, but in theory, Prometheus is better scalability than Grafana. Because remember, in this case, Prometheus pulls the data from your microservice, right? So if Prometheus is too busy to do any more work, then it doesn't bother pulling, right? With Grafana, you have to send your metrics to Prometheus. So, that's one thing that's very distinct about Prometheus is that it pulls instead of pushing, right? The other thing that's nice about Prometheus is that it supports dimensional metrics. What I mean by that is normally when you think of Grafana or lots of other time series databases, it's keys and values, right? I have a key and I have a value. It's like a map. But really, if you think about how people care about metrics, it's not just one key and value. They have a whole map full of keys and values. So, for example, let me show you my screen here. Okay. Imagine you're using Grafana and you want to have HTTP.requests, okay? And you can add a counter, right? Okay, well, what if you want to have HTTP requests and you want to know which ones are HTTP GETs? Okay, no big deal. And what about GETs and the status is 200? Okay, no big deal. I'll create another label, right? You see the problem here? Now, as I decide to add more metrics, I need to remember all the different combinations of keys, and it's up to me every single time I emit a metric to add these other ones. This is what you get with Grafana, because you only have keys and values. With Prometheus, you have dimensions, so you can actually say HTTP.requests, right? That's the main metric, but you can also have like a nested bag or nested collection of other metrics. So verb, get status, 200, whatever, right? So now it's included, and you don't have to. You can change just this, and as soon as you when you commit this metric, you can update these, but they're included, right? So you can't accidentally create a metric that doesn't exist already, right? It's all part of the same data set, and you can then easily query it. You can say, show me all the HTTP requests where the verb equals get, right? So you can do ad hoc queries later on, just like a SQL database kind of. With regular Grafana, A.B, if you know the key is A.B, great. But if you don't, there's no way to do a query to find out, right? So I prefer things like Netflix Atlas, things like Prometheus, because they give us dimensional metrics. And of course, Spring uses an amazing library called Micrometer. Micrometer is what's supporting the metrics collection in Spring. And Micrometer is starting to, you don't need Spring to use Micrometer. But when you use metrics with Spring, you use Micrometer. So it supports really good integrations for AppOptics, Azure Monitor, Netflix Atlas, CloudWatch, Datadog, Dynatrace, Elastic, Ganglia, Graphite, and Grafana, of course, Humio, Influx, Telegraph, JMX, Kairos DB, New Relic, Prometheus, Signal, Wavefront, which is a VMware. I love this one. So all these are fine, right? They're good choices, and you can use Micrometer with simple key value store style time series databases, but generally prefer the new stuff. Prefer things like Atlas and Prometheus and Wavefront and so on, and InfluxDB and so on. So I hope that helps.
Yeah, for sure. Another question. is how about the coupling of customer order classes between the customer order microservice and the gateway? If one of them changes in one microservice, then we have to propagate changes in the gateway.
Absolutely true. Yeah, I mean, in my example, I was just doing copy and paste. There's two ways to solve this. I'm sure you know about them. One is either some sort of schema, right? Some sort of mechanism you can use to validate the object over the wire, and then another thing that comes out of that might be code generation, right? So maybe you do that. The other thing you can do is to do something like consumer-driven contract testing. And what consumer-driven contract testing does is it validates at test time whether the client-side representation of a type matches the foreign service representation of that type, right? But I just copied and pasted. RSocket is platform independent, so you can use RSocket with Python or .NET or whatever, anything else. It doesn't have to be just Java. So however you decide to create a representation for that type is kind of up to you. Consumer-driven contract testing is very easy with something called Spring Cloud Contract. So check that out. That way you can have a copy, but if you decide to use it and you make a request that doesn't match, it'll break the build, right? So you don't find out at runtime, you find out at development time.
Okay. We have also a question, RSocket question. I no problem using RSocket in Kubernetes for inter-service communication, in particular regarding the LB over multiple pods.
Yeah, so RSocket over Kubernetes is kind of interesting. We actually have like I said, one of the things I'm really excited about is the broker, right? That broker will give you load balancing, and you can tell Kubernetes to skip load balancers. You don't have to have a load balancer for a pod, right? You can actually just have direct communication to the pod. You can get the IP, for example, the IP of the service as opposed to DNS. So for RSocket, since it is stateful, I would recommend just going straight to the pod and then having something like the broker do the load balancing for you. That said, you can, if you really want to, because RSocket supports session resumption, right? Because it supports the ability to resume the connection. In theory, you could actually just force your RSocket connection to reconnect. And if you have session resumption, you can actually reconnect on a different node, right? And then that'll be transparent. That would be very wasteful, but technically it could work, whereas with HTTP, it's not going to work.
Okay. This question is from us. How is the performance of Spring Cloud Gateway compared to other Node.jvm-based gateways?
I don't know. It's really fast, super fast, but I don't know how it compares to other ones. There's Kong, right? There's Nginx, there's Mod Rewrite, and Apache. Remember, not all of them are doing the same thing. There's for example, Spring Cloud Gateway does a ton of stuff, but it doesn't do everything that Apigee does. Apigee, for example, is much bigger, right? So maybe if you're using Apigee, if you have like a one use case that you can't do with Spring Cloud Gateway and you don't want to build it, then you might use Apigee, and Apigee is much bigger. So it's very hard to compare, but it is really, really fast. And people use it for like an ingress controller, right? You can actually drop out the ingress inside of a Kubernetes. You can replace it with something like Spring Cloud Gateway, just like people do for Nginx, right? You can also use it as a route service on Cloud Foundry, right? Cloud Foundry has the ability to do the same. It's basically the same idea. It's a service that sits there as the first port of call. So you can do really amazing things with it. I don't know what the speed numbers you want are, but try it out. It's very scalable, very fast.
Okay. Last question is about GraphQL. Any development on for GraphQL?
Great question. Yeah, I think so. I think I just saw, I don't know, let me check here. Okay, so give me github.com, Spring Projects Experimental. I think I saw something, but I don't want to speak without being sure. Yeah, so if you go to, can you see my screen? You cannot see my screen.
You have to share it.
Sorry.
Okay.
I've never used a computer before.
Don't worry, don't worry.
Okay, my friends. So here's an experimental project that we're working on. It's not GA, but it's open source. You can see it, right? It's right here. It's called Spring Projects Experimental Spring GraphQL, and it was worked on by Rossen Steinchev. He works on the Spring Web support, all of the Spring Web support. So RSocket and Reactive Web and WebSockets, all that, it's his code. And he added a bunch of commits just 9 days ago. So it's obviously important people that would need to do important things are working on it, and they've been working on it recently. But I can't tell you how good it is or anything because I haven't tried it. So it's tested against Spring Boot 2.4, but should work against 2.3. You can add this to the starter, to the build. And then runtime wiring customizer, customize runtime wire, blah, blah, blah. Configure the Spring GraphQL path.
Okay.
And then blah, blah, blah. I guess that's it. I'm not sure. You should try it. I haven't done it yet.
Yeah.
But I hope that's the answer you're looking for. And if that helps.
Yeah, the talk was really, really interesting. So thanks for your time.
So it looks like there's, let me see, any concern on using RSocket and Kubernetes for service-to-service communication?
Yeah.
No, I recommend using it. Let's see, who else is...
This one, I'm using RSocket in Cube for service to service com.
Any examples on using, would be great to have like a storefront example, microservices plus reactive security plus messaging. I think we have a Spring Pet Clinic.
Yes.
We have a Spring Pet Clinic cloud native version. So if you look for Spring Pet Clinic cloud, that's the right one. So if you, I'm not sure if this is reactive though, but if you, let's see, share screen. Okay, so if you go here, this is a microservice version of an e-commerce store, or a store, like a storefront. It's a pet clinic. It's kind of like a storefront. And it's deployed to Kubernetes, and it's microservices and all that kind of stuff. So maybe that'll help. I'm not sure if it's reactive, but it could be very easily, right? That's separate, I guess. Let's see. Main. That's service. Very hard to tell. Model, repository. No, it's not reactive. It's regular. It's not a reactive one, but maybe it helps you.
Yeah, we have another question. The last one.
Yeah, take your time.
Okay, this one is about web clients on RPC. So,
like I said, we have gRPC support, which is very. It's not part of Spring, right? So it's very popular, but there's other ways to do it. There is a plugin from Salesforce. Salesforce is a large company here in Silicon Valley. I live in San Francisco, so actually their building is just right there, the Salesforce building. But that plugin allows you to generate Reactor-based gRPC services, right? So it's using Project Reactor, which is what we're using for all the reactive stuff that I've showed you. And then that's kind of interesting. As to what it means to be on the web, I don't know. I mean, I don't know much about, I'm not sure if I understand your question, but if gRPC works on the web, then it still works on the web. I don't know.
Don't worry. Okay. Thank you very much.
Thank you.
A great pleasure for us.
My pleasure.
Okay.
Appreciate your time.
Bye.
Bye. Ci vediamo.
Ciao.
Ciao.
Ciao a tutti. Hello everyone. It was a great talk, and I remember also our links for our community. Share screen. This is our community. The links for our community, YouTube channel, Facebook, and Discord server. Was a pleasure for Italian coders have John Long. So thank you so much. Bye bye.